So this is my personal timetable. Uh, Today I am going to explain uh, first I'm going to explain the previous paper, and then I'm going to explain all the further details. Towards non-invasive core body temperature sensing. Abstract of that paper was uh, the potential of novel radiometry technique biomatch the antennas stands for BMA, broadband measurement and forward modeling of layered tissue for non-invasive and accurate core body temperature monitoring. The penetration of electromagnetic wave in different paths depending on their frequency and their dielectric properties of medium. Primary modeling and experimental result confirm the feasibility. Thermal electromagnetic radiation. In thermal electromagnetic radiation, uh, have three different kind of radiation: ultraviolet radiation and visible and infrared rays, which lies under the 1 to 10 raised to 2. Now the introduction part, uh, the basic definition of core body temperature is defined as the temperature of blood bathing the hypothalamus, the contact with the body, other highly perfused core organ. This method include esophageal, nasopharyngeal, and pulmonary arteries thermometer. The companies such as 3M Draeger have begun offering zero heat flux thermometer. Zero heat thermometer do not work at the temperature less than 32 degrees Celsius, which is well within the temperature range of for life, namely 18 degrees Celsius to 46 degrees Celsius. In the clinical case, the radiometer was tested during pandemic surgery with 1 to 2 degrees Celsius error throughout the experiment. Now, the uh, internal thermometer such as oral, rectal, and esophageal, not portable. It is not convenient for long-term monitoring, difficult to insert, indigestible. Telemetric pills measure temperature while digestive tract of limited period, not reusable, and the precise position in the body is unknown. Uh, Now the surgical inserted thermometer, implanted thermometer are not invasive. Now the external thermometer, such as MRI, grant high spatial temperature resolution, but are expensive and not portable. Uh, and the other active external thermometer such as CT stands for computed tomography, imagining and ultrasound, an isothermal tunnel develops below the skin surface, which makes the subsequent temperature equal to skin temperature, where it can be measured non-invasively. And now today I'm going to explain what is RF sensor, how it is used, and why it is used. The first and some basic informations like RF and microwave power meter are used in various area: RF design and development, test service, repair, and field service. The RF power meter are available in different types such as inline, observative, etc. Most of this type come with an RF sensor which is used to measure RF power. The type of sensor that will be used for measuring the power usually depend upon the type of signal that need to be measured. A few type of sensor are suitable for measuring low power while other are applicable for modulation techniques. What is what is an RF power sensor? RF power meter is an instrument which can be measured the electrical power, mostly in range of 100 megahertz to 40 gigahertz. This meter consists of a RF power sensor that is connected to it via a cable and can be display power reading, also referred as amount that operate by defining sensitive volume and interrogative the value of parameter for different material that invade this volume. Volume that can be defined by ratio frequency antenna which turned into sensor electronics. And now how this RF power sensor work? It's just like a RF material. A power sensor has four electromagnetic parameters such as real, imaginary of the electrical primitive and magnetic sustainability. A sensor that operates by defining a sensitive volume, integrating the value by this electromagnetic parameter. Frequency. The radio frequency antenna is used to define the sensitive volume, which is turned into sensor electronics. And type of RF power sensor. The large range of sensors that have their own distinctive features, advantage and disadvantage. Type of sensor is directly depend on the type of signal that needs to be measured. Be a few types of applicable to low power while other are modulation technique. Based on these parameters, some of the common type of sensor are follows: diode detector based RF sensor and heat based. These are the two type of RF power sensor based on the parameter of some common type of sensors. Detector based RF sensor generally used for analog power meters. This technology can also be used for high performance power meter. The main advantage of using this type can help to measure signal for extremely low level of power and respond quickly as compared to other type of heat based varieties. The RF power sensor use this diode make it possible for RF power to get dissipated in load. The detector that reflect the voltage signal that appears across the load make it possible to determine the power level entering the load. The first one involve their ability to measure low power, and the second benefit of this sensor involve their ability to respond quicker to signal as compared to the heat based one. And the first, which involves ability to measure low power, the RF sensor can measure power level as less as minus 70 dBm, which value quite lower as compared to measure done by using heat based. Now, the second type of RF sensor is heat based, generally used to dissipate the power from the source in load, then measure the resulting temperature rise. Advantage of sensor are measure to the true average power of heat, that is despite in form of power integral input over time. This power sensor measured the RF power limit of signal regardless of this waveform. Now, mainly are two types of heat-based sensor: thermistor RF power sensor and thermocouple RF power sensor. In thermistor RF power sensor, the power sensor make use of principle that rise in temperature can happen due to heat caused by ratio frequency passing through the medium used. This can enable DC power to get sustained so that system can properly calibrated. In thermocouple RF power sensor, uh, take into the account a square law characteristics which indicates the input RF power to the proportional to DC output voltage from the thermocouple sensor. Now, why we should use RF sensor? Where every equipment has some key advantage that define the actual purpose of that device. Here are the few advantage of using this RF sensors. It does not require any additional components such as magnet, coils, etc. And it has a high single to noise ratio that can maximize by optimizing the sensor design for a particular application, and it output is depend on speed unlike inductive sensor. Thank you.